secants, tangents, and angle measures. As just a little review from yesterday, we talked about tangents, and we said that's a line that intersects a circle exactly where? In how many points? 1 point. 1 point. And it is, what's its relationship with the radius? It's perpendicular. You can put the symbol if you know the symbol. If you don't know the symbol, you should write out the word.
It's upside down T.
It is the upside down T. The upside down T, perpendicular 90 degrees, right? Today we're going to talk about a secant. It's pronounced secant, not second. A secant is a line that intersects a circle in exactly 2 points. So if I have a circle and I draw a line that goes through it, it doesn't have to go through the center. It can go through anywhere it wants to as long as it hits the circle in 2 places. We don't have a point of secancy like we have a point of tangency because there's 2 of them. Okay? So that's secant, then there's tangent. The only other way a line can have a relationship with a circle would be that it doesn't touch it at all, right? Because you can't have a straight line go through a circle more than twice. Okay, so it's either it goes through the circle and hits it twice, or it sits right next to the circle and touches it once, or it's outside the circle, it doesn't touch it at all. Those are the 3 options. Okay, and if it doesn't touch the circle at all, we don't really have a relationship. All right, so when a secant and a tangent intersect at the point of tangency, so if this is a tangent, so here would be the point of tangency, and if this is a secant, and so it intersects in 2 places, okay, it divides the circle into 2 arcs. If the secant goes through the diameter, it divides it into 2 180-degree arcs. If it doesn't, it's going to have a major arc and it's going to have a minor arc. Okay? And there's a relationship just like with the inscribed angle. I'm going to have, we just did that math minute warm-up where we looked at linear pairs of angles. So I know if I look at that angle and I look at this angle, I know together they're supplementary, right? So if this one is 100 degrees, then I know this one would be 80 degrees. Okay? This says the measure of each arc is 2 times the measure of the angle formed on the corresponding side. So that means the arc, the major arc on this side, would be 2 times the 100, so that would be 200 degrees. And then the arc formed on this side would be 2 times the 80, so that would be 160 degrees. And then notice that makes the whole circle 360 degrees. Okay? So it works just like an inscribed angle, where the angle is half of the arc. Okay? And remember, you're going to end up with 2 angles right there at the edge of the circle, and they'll be supplementary because they're a linear pair. Okay? So when I look at these examples, it says label each arc measure and each angle measure. So I can see on this one, they gave me this arc is 130. So how big is the angle that goes with it? How much? 65. Because I had to double the 65 to get to that 130. So then I have 2 options to figure out the other side. I can either take the 130 away from 360, right, the whole circle, to find this arc. So I could take 130 away from 360. Or I could say, well, I know the 65 and this angle are a linear pair, and I can take the 65 away from 180 like we did in the warm-up. Okay? Either one will work. So I could do 360 minus 130, which would give me 230. Or I could do 180 minus 65 for the angle down here, and that would give me 115. Notice no matter which way I do it, I'll end up where the angle is half of the arc. 115 is half of 230. Okay, so when I look at the next one, I can see that they gave me this angle is 125 So what's the measure of the arc that goes with it? 250. So what do you want to do to find the next arc or the next angle? Do you want to use the 360 or do you want to use the 180? The 180? Okay, so 180, take away 125, is going to be how much? 55? So this angle here is 55 degrees, which means the arc is double that. So how big is the arc? How much? 110. Questions? Okay. When you have secants and tangents, and they intersect near a circle, there's only 3 places where the 2 lines can intersect. They can intersect on the edge of the circle, on the circle. They can intersect inside the circle. And notice I'm not saying it has to be at the very center. It can be anywhere inside the circle, like that warm-up we did. Might have the intersections of the chords all over the place. Or they could intersect outside the circle. Okay? So what's going to happen is there's going to be 3 different methods for finding the angle at which those lines intersect. Okay? So I already know if it's on the circle, that really, I don't care about the left-hand side, I only care about the right-hand side. If I'm looking at this angle right here, we already know that that's called an inscribed angle. And we already know if you have an inscribed angle, it's 1/2 the measure of the intercepted arc. So that's old news. We already knew that, right? And notice it even works for up here, right? Because my intersection is on the edge of the circle, and that angle is 1/2 the intercepted arc. That angle is 1/2 the intercepted arc. Okay? Questions? Okay. The other thing is it could be inside the circle. If it happens inside the circle, then let's say I'm talking about this angle. I know that angle is vertical to this angle, so those 2 angles are the same. And if it was right exactly in the center, then I would know it was a central angle and it would equal this arc. But if it's not exactly in the center, then when I go to the other side, it goes to a different sized arc. So they can't be equal to the arcs. And since they're different, you can't just take 1/2 of the arcs because you get 2 different answers. Okay? So here's what we do if it's inside the circle. That angle that we want to find is going to be 1/2 the sum of the 2 intercepted arcs. 1/2 the sum of the 2 intercepted arcs. Okay? And then the third situation that can happen is if I have 2 secants, they could intersect outside the circle. And if they intersect outside the circle, then I would still have these vertical angles here and here. And so to find that angle, since that intersection is not exactly on there, I'm going to still intersect. As I come out, I'm going to intersect this tiny little arc. And then as I keep going, I'm going to intercept this big arc out here. So I'm going to intercept 2 different arcs. The last time we said it was 1/2 the sum of the 2 arcs when I was inside. Guess what it is when it's outside? What's the opposite of sum? Subtraction, which we call the difference. So when we're outside the circle, it's going to be 1/2 the difference of the 2 intercepted arcs. It's important to note that when you put your arcs in, you always want to put the furthest away arc first. Because that's always going to be your biggest one. And if you put a big number minus a small number, you get a positive. But if you do a small number minus a big number, you get negative. And we don't do negative angles. So you're always going to do the far away arc minus the furthest in arc. Okay? Ready for some examples? All right. Examples, find each measure. Assume that segments that appear to be tangent are tangents. I'm allowed to say that looks tangent, it is. Okay? All right, so the first one, number 1, wants to find is the measure of arc WX. So this arc right here. So that has nothing to do with anything we learned today. That's just what we did like that first or second day of this unit. I know how many degrees are there in the whole circle? 360. I've already used 80 and 160. So 80 and 160 is how much? 240. So what's left for that orange arc? How much? Yeah, 120. So that wasn't really what we were doing today. That was just reminding us that we still need to remember all that old stuff. Okay? But now if I want to find the measure of angle Z, is that inside, outside, or on the circle? Outside. So if it's outside, that means the angle is 1/2 the difference. So that angle, angle Z, is 1/2 the difference of the two intercepted arcs. So as I come out of angle Z, I hit WY, and then as I keep coming out, I hit XY. We always put the bigger of the two arcs in first, so we get a positive number. So my two arcs are 160 and 80. So the measure of angle Z is 1/2. What's 160 minus 80? 80. And half of 80 is 40. That's it. Yeah. All right, the next one, I don't know what happened. I already fixed it for next year because, yay, I already fixed it, but that doesn't help us. This J is supposed to be way over here. This is supposed to be J right here. That dot is not in the wrong place. That's just showing you where the center of the circle is, showing you that J is not the center. Right? These are not central angles. Okay? And then that 45 degrees is for this angle right here. Okay? And we know from the warm-up we just did, we reviewed that these two angles are vertical, so we know they're both 45. The first thing it asks me to find is the measure of angle FJE. FJE, how big is FJE? 45. They're vertical. That's what we did in the warm-up today. And then the measure of angle FJG, FJG, F to J, J to G. We did that in the warm-up today also. How big is FJG? 135, because the orange and the blue together are a linear pair. So they have to add up to 180. Okay? And then the measure of arc GH, that's here. The measure of arc GH goes with what angle? 45. And then what's the other intercepted arc? 28. That angle that it goes with, the 45, is that inside, outside, or on the edge of the circle? Inside. So that means my angle is going to be 1/2 the sum of the two intercepted arcs. So my angle is 45 degrees, the angle that's made when my chords cross here. 45 degrees is 1/2 the sum of the two arcs. One arc is 28. The other arc is what we're trying to find. We're trying to find the measure of arc GH. We don't know that. You could just put an X if you didn't want to write that whole thing down. Now, here's what I like to do. You could distribute that 1/2, but I personally don't care to work with fractions any more than I have to. I don't know about you. I like to see, can I get rid of that fraction as soon as possible? And if I distribute it in, yes, the 28 divided in half will be 14. So that'll get rid of a half, but I'll still have a 1/2 multiplied to the measure of arc GH that I'm still going to have to deal with. So what I do is at this point, anytime my variable is inside these parentheses and I have this 1/2 on the outside, I get rid of that 1/2 by, what's the opposite of dividing by 2? I multiply both sides by 2. Because then I don't have a fraction and we no longer have to worry about that 1/2. And fractions are gone. So 45 times 2 is 90. And that's going to equal just 28 plus the measure of arc GH. How do I get rid of the 28? Subtract it. 90 minus 28 is what? 62. So that is the measure of arc GH, is 62 degrees. Questions on 2? Okay. Number 3. It wants me to find the minor arc and the major arc that are formed by these two external tangents, or tangent segments. Okay? And then it also gives me a hint. It says to think of the minor arc as x. That's going to be really helpful. Anytime you have this and you don't know any of the measurements on the circle and the two arcs that are being intercepted, so right, if I go like this and I go out, I intercept this arc, and then as I keep going out, I intercept the rest of the circle. So the whole circle is really intercepted. Always call the inside arc x. And then my outside arc, I know the whole circle is 360. So if I knew what this is, let's say it was 100, I would do 360 minus 100, right? If this was 140, we would do 360 minus 140, right? Whatever this inside arc is, to find the outside arc, we would always do 360 minus whatever that inside arc is. Okay? So now I have expressions for both of my arcs that are intercepted, and I have my angle, which is where inside, outside are on the circle. Outside. So since it's outside the circle, I know I'm going to say the angle is 1/2 the difference. So that angle, 50 degrees, the angle that's outside, is 1/2 the difference. Remember, you always put your bigger arc, the outside one, in first. So I want to put in that 360 minus x first. And then I'm going to take away the inside arc, so minus x. Again, the first thing I like to do is get rid of that 1/2. If my variables are inside the parentheses, I get rid of the 1/2 because I don't like it. So I'm going to multiply both sides by 2. So I'm going to end up with 100 equals 360 minus x minus x. But I can combine my minus x's. I'm really going to have minus how many x's? Minus 2 x's. What should I do first? Okay, let's subtract 360. That's going to give me negative 260 equals negative 2x. Then what? Divide by negative 2. And x equals positive, because negative over negative, 130. So x is 130. That's my minor arc. What's my major arc? 230. Because together these have to make a whole circle, 360. And you can check it. If I take my major arc and I find the difference between the two, my difference is 100, and half the distance, the difference is 50, which is what that angle is. So it worked out for us. Okay? And these are arcs, and they're measurements of arcs, so they're degrees. Okay? Number 4, find the measure of angle QRS. Is my angle inside, outside, or on the circle? On the circle. So if it's on the circle, this we've already done before. The angle is 1/2 the arc, because there's only one intercepted arc. It's just this right here. To find that arc, I know the whole circle is 360 degrees. I've used how many? 260. So that means this arc is 100. So the angle, the measure of angle R, is 1/2 of 100, which is 50. Questions? Okay. The next one, number 5. The measure of angle R. Inside, outside, or on the circle? Outside. So that means my angle is going to be 1/2 the what? Difference. That angle, the measure of angle R that I'm trying to find, is 1/2. When I come through, I see I've got 40 degrees. And then as I keep going, I can see I have 80 degrees. Which one goes first? 80. 80 minus 40, half of that, 20. 20 degrees. Questions on 5? Okay, let's go to 6. Number 6, the measure of angle X. So here's X. I can see it's where? Inside, and the intercepted arcs are 52 on one side and 40 on the other side. So if it's inside, the angle equals 1/2 the what? Sum. So that angle, angle X, is going to equal 1/2. The two arcs are 52 and 40. So that's 1/2 of, what's 52 plus 40? 92, and half of that is 46. Find the measure of angle V. Angle V is inside, outside, or on the circle? Outside. So that means the angle is 1/2 the difference. As I come through, I can see I have this arc that I don't know how big it is. And then as I keep going, I hit this arc that's 100. So that angle V is 1/2. The outside arc is 100. How can I find the inside arc? Yeah, subtract all the other arcs from 360. So if I look at all the other arcs, I have 110, 100, and 80. So that's going to be 290. I take that away from 360, which leaves me with how much? 70 for this arc right here. So the measure of angle V is going to be 1/2 of 100 minus 70, which is half of 30, and half of 30 is 15 degrees. Number 8 wants me to find the measure of angle X. Now here is an interesting problem. Here's X. It goes with this vertical angle here, and it goes with these arcs. Those are not the arcs I've been given. The arcs I've been given, if I use these two arcs, the 90 and the 130, that's not going to find x, that's going to find this angle. So I'm going to find the wrong angle, but once I find the wrong angle, I can use that to find x, right? Because we did that in our warm-up. All I have to do, once I find the blue angle, what do I do with that to find the orange angle? Subtract from 180. Good. So I'm going to find this angle. If you want to give it a variable so you don't have to write it, you can give it a variable. I could call it y. Is it inside or outside or on the circle? It's inside. So that means that angle y is going to be 1/2 the sum or the difference? The sum of 130 and 90. So y is going to be 1/2 of how much? 220. So what is y going to be? So if y is 110, these are both 110, how big is x? 70. Because they're linear pairs with the blue angles. So the measure of angle x is 70 degrees. Okay. Last but not least, I have find the measure of arc Tr and the measure of arc Tsr. So I see I have 98 degrees there, which means how much do I have on the other side? 82. So if I want to find the measure of arc Tr, so that starts at T, it ends at R, and it goes the short distance around. How big is the measure of arc Tr? 164, double the 82. All right, and then the measure of arc Tsr says I start at T and I end at R, and I have to travel through S. How big is that one? 196, double the 98. Any questions on any of these?
Can you show the front again?
I can. So just make sure that you're paying attention to looking at whether your arcs are inside, outside, or on the circle. That's really the main thing there. Oh, I did want to show you one other thing before we go. I told you I was going to do this when we did this problem, and then I didn't because I don't know what happened. I got distracted. But before you get off topic, pay attention still one more time. I'm going to show you why I always call this inside angle x instead of the outside angle x. If I were to call the outside angle x, then that means this inside angle would be the 360 minus x. And then I'd have my 50 here. And so then what's going to happen is there's going to be a really common mistake that is going to be super easy to make. If I call the outside arc x, then I've got my inside arc is 360 minus x. So when I do, that angle 50 is 1/2 the difference. My outside arc minus my inside arc is going to be x minus, I have to subtract that whole thing. So I have to put the 360 minus x in its own set of parentheses. And that we forget to do every single time. Because what's going to happen is I have to distribute this negative. So that I end up with 50 equals 1/2 of x minus 360 plus x. Multiply both sides by 2. And then I have 2 x's minus 360. So then I would add 360 to both sides and get 460 equals 2x. Divide by 2 and get that 230 equals x. Which is what we said the big arc was 230, right? The major arc was 230. So you'll still get the correct answer, but I would say probably 7 times out of 10, which 70% is like a lot of y'all, okay? We forget to do those parentheses, so then we end up with minus 360 and minus x, and then you're like, wait, my x is canceled. I don't even have an x in my problem anymore because I had a plus x and I had a minus x, and now I don't know what to do. And then you're completely lost. So rather than doing that, don't do that. Always put your x, when you don't have anything on there, always put your x first, okay, on the inside. And here was the first page, for those of you who came in a little tardy. Oops.